Hi everyone, this is Plasma call number 3. So I guess we're going to have some new people and some old people will not be showing up this time because, it's winter and spring and people are traveling as always. So this call is getting possibly a little bit big with the participants. For the new people, well, I guess everyone existing, I guess, say hi. I guess introductions are not necessary, but for the new people, maybe introduce yourself. I'm Joseph. Hi. I guess it's turning out that me, Carl, and Vitalik are running these calls. I think Vitalik possibly can't make it today. I think he might be traveling or something. But yeah, everybody else, hi. Oh, wow, we have a baby too.
Yeah.
Nice.
Hi, I'm Enran. I'm from Taiwan team, and as you see, I'm taking care of my kids, and so I will keep mute for the rest of the meeting, and I will be a listener. Nice to meet you.
Okay. Yeah, nice meeting you. Very cool, very cool. And you're part of the Taiwan team?
Yeah, I'm part of the Taiwan team, but I'm currently live in New Jersey. So it's
okay.
1 p.m. Yeah.
Okay. The newer version of it, right? Not the older one.
Sorry,
I was making a joke. New Jersey.
Yeah, New Jersey.
Yeah,
pretty close to New York. It's about an hour from New York City.
Yeah, very cool. Yeah, very cool. And I guess the baby is going to be helping us out as well. Cool. Wow, can we see the front of the baby? Or is he sleeping? He's sleeping. Let's not mess with him. Okay. I guess.
Okay. I will close my video for now. Yeah.
Okay.
Nice to meet you.
Okay, nice meeting you, and nice meeting you, baby. Okay. Maybe Carl and David.
Hi, I'm Carl.
It's Carl.
It's Carl. I do Ethereum research and videos and stuff.
And then I guess another person previously on the call, David.
Hey, I'm David.
Okay, and then I guess maybe the Cosmos team, and then everybody else introduce.
Hey, Sunny,
Zucky,
Adrian.
Cool.
And Juden is also from the Cosmos team.
Oh yeah. Oh, okay. Hi, June.
Hi. Nice to meet you.
Hi. Oh, sorry. So this is Ben from Consensus. So I'm in Protocol Engineering Group. Plasma is something that we will be working on. At the moment, it's pretty much a watching brief for us. I may have another colleague who will join from the next call who will be working more closely on that.
Okay, cool.
It's nice to be part of this. Okay.
Okay.
Oh, hi, my name is Tan Xiang, and I'm also from Taiwan team, and I'm with Enran and Wilson and another guy called Andy who is not here right now, and we just learn from everybody and just want to do something about this MVP Plasma. Very cool.
It's nice to meet you. Oh, what was your name again?
My name is Tan Xiang.
Okay.
It's hard to pronounce.
What do you go by? Tan.
It's okay, I think.
Okay. Oh, is that okay? First name, is it Xiang?
Actually, my family name is Xu.
Xu. Okay.
Yeah. Or you could call me. Yeah, you just call me Sean. It's fine.
Okay, Sean. Okay, cool. So nice to meet you all with the new people.
Hi.
I guess
we have one more.
Oh, what?
Okay. Hi.
Oh, I'm so sorry. I thought I saw you wave.
It's okay. As I mentioned, I'm Wilson and I'm part of the Taiwan team. Just call me Wilson. Yeah.
Okay, Wilson. Nice to meet you.
One before we dive into the technical stuff, one logistical thing. So
I have one more
this.
too.
Okay, cool. Well, this time, I think the reason why Vitalik is not here is because I think it's something like 3 a.m. in Taiwan or something.
Oh, I'm so sorry.
Oh,
yeah.
actually, it's 2.
2. Okay.
Yeah.
2. Yeah.
And I think so. I think Vitalik's asleep. Maybe.
Oh,
I mean,
okay.
that's my theory.
Okay.
And so
how early can we make it? How late can we make it?
You think
So is 8 a.m. plus 2 hours earlier better for you, everybody?
Yeah, for Berlin this would work.
It works on my end.
How about Taiwan? Is this I think that's 12, right? Is that too late?
Yeah.
Too late.
12. I think.
I think 2.
Yeah, a
maybe
little.
2 or 3.
Yeah, a little bit too late, but I think.
11 p.m.
Yeah, 11 p.m. will be better, but I think it will be hard for you guys because we have a different time zone.
Can we do?
How early can you get up, Joseph?
Can we do? That's 7 a.m. Pacific. Okay, what if we did? Okay, this is gonna sound crazy. What if we did 6 hours earlier?
It's like,
So it's like.
Oh, then it's too early for you, David.
that's like 4 a.m. I can. Yeah.
Never mind. Okay, fine. Let's do 7 a.m. Fine. Let's do 7 a.m. I'm just gonna have a lot of bad jokes. That's okay. I'm tired of
Totally
bad
fine.
jokes.
Okay.
Is that what happens? Okay, so like, what do we do in the crypto space? This is like an interesting problem. We're gonna spend like a 5-minute divergence on this topic, but like, let me go on like this like rant. Like, what's interesting about the crypto space is everybody flies in together and then disperses. That's sort of like how things are organized. And I think people outside the crypto space actually don't know this. They actually don't realize this is how stuff gets done. And then for calls, like right, like people are nodding their head, right? You know, but it's just like nobody knows this, and it's kind of interesting. Everybody just flies in, flies out, flies in, flies out. It's like flies into the same event together. Like 50 people show up, and everyone disperses back a week later. It's just like, oh, it's so digital, but like people show up physically. But for like video conferences, it's just like everybody's all over the world, right? So what happens is that literally everybody throws Hawaii and New Zealand under the bus because there's no way to make them happy. So those guys have to wake up in the middle of the night, right? And then Pacific time, we have to wake up at 7 a.m. for things. That's like, Jesus. And everyone else has like great schedules. So yes, I'll do it because there's no other way. 4 other calls where they're just like, maybe there's some other way. No. You gotta be a morning person.
Yeah. So at Cosmos, we've been using UTC to like talk about like when we're gonna have meetings. I think maybe the next step is force that everyone like follows UTC like sleep schedules.
Yeah. Oh, yeah, we'll do that too. Done.
Then we should call UCC.
I'm already doing it. I'm in London.
I have a UTC sleep schedule. It's working great. All right. No, I just had to get out there because if I'm going to be waking up at 7 a.m. every Wednesday, I just needed a quick rant to make myself feel better. Sorry, that was a little bit of an indulgence, but yeah.
Good one.
Okay, 7 a.m. I will adjust the calendar and then like stop complaining. Okay, and I will do this one starting next week. So okay, that was one of the 2 items logistically. The other item logistically, I will do that right now. Can you have co-owners of like calendars?
Yeah, I wasn't sure.
Dang it. Okay, I was going to do today's. The next one's 21st, right? Oh, great. It's not even 28. Okay. So 7 a.m. Pacific?
Yep, sounds great.
Yeah.
Okay. Okay. I'm going to assume 7 a.m. Pacific, but when we start doing the daylight saving stuff, those 2 weeks might get a little wacky and we might just adjust or cancel our meeting.
Sounds good.
Too wacky. Okay. This and following events, save, send. Cool. Okay.
Sounds good. So maybe the like Taiwan team, do you want to just give kind of where you are, what you have implemented, what is, you know, remaining, what you're working on right now?
Okay. Follow the Vitalik spec, the minimum viable plasma. We developed a JavaScript version of plasma chain and Solidity smart contract, a plasma manager contract yet, and so far we can deposit and we can have a transaction in the plasma chain and we can withdraw, and withdraw have to wait for about 1 week to challenge. Yes, and it's just some basic feature, and we I think we done the basic feature, but yes, and now we are moving forward, moving on to the about merging the transaction, because advice from the Vitalik, we want to simulate the account base by UTXO base. Yes.
Oh, have you talked to David about this topic? The UTXO and account-based stuff?
Sorry?
Have you talked to David about it? David not?
I don't think so.
Oh, okay.
No.
It's something that David is thinking about actively as well, and could be interesting for you both to explore. And it could start the conversation or perhaps more deep collaboration. You know what I mean? But yeah, I think that could be interesting. I don't know. Could be. If we want to dive deeper into that today, we could as well.
Okay.
Okay, cool. That sounds interesting, and really like. Sounds like you guys have done a lot. Yeah, that's really cool. David?
Yeah. So I got the command line working, and that's but I've really been spending most of my time thinking about the spec itself. And so kind of what I've been thinking about is how we could potentially get rid of confirmations by adding in a few rules and a slashing condition. So I can go into further detail with that if you're interested.
Yeah, we're interested.
Awesome. Cool. So basically, the two main rules are that each child chain transaction is signed when it's created and it has to be included within 2 child chain blocks. Otherwise, it's just invalid. Then for each transaction, you can only use inputs that were created in a child chain block 3 or more blocks back. And so those are the 2 main rules. And then,
sorry, what were the 2 main rules?
So for each transaction has to be included within 2 blocks of the time it was created on the child chain. And that's tracked off block submission to the root chain.
Wait, so each block must be
each transaction. So each child chain transaction must be included within a child chain block that's submitted to the root chain within 2 blocks.
What if it doesn't get submitted to the root chain within 2 blocks?
Then it's invalid.
Wait, I'm kind of
So
confused.
what if there's a backlog of transactions on the root chain?
What do you mean a backlog of
like
transactions?
what if like it gets into the root chain like 5 blocks later?
Then it doesn't. It's not valid, and someone would have to resubmit the transaction.
What's the reason for that?
The reason for that is because it basically limits the potential attack if the operator is block withholding. So they either need to include the transaction and within 2 blocks or not. And
what does that get you if they are block withholding?
It basically gets you. So it makes more sense. Can I finish explaining it? What's happening?
I'm sorry.
Yeah. So when exiting, basically, the main downside to this is it basically takes 3 Merkle proofs, at least right now, instead of 1, because you're basically proving a transactions and exiting transactions, its validity, and checking its inputs. And because the inputs have to be 3 or more blocks back, when you submit a child chain transaction that is only valid for 2 blocks, you basically assume everything 3 or more blocks back is valid. I have a spec, and it'd probably be easier to understand based off that.
And around the spec, that'd be great.
Yeah, and I'm currently right now. I can share it right now. I'm currently updating it because I showed it to Vitalik yesterday, and he poked a hole in it. And so right now, confirmations are still the way to go, but it's a work in progress, and I can share the work in progress.
Okay, cool.
Yeah. And then, yeah.
Yeah, I'll review that and get back to you pretty soon with that.
And then on a different side of things, I've been thinking about ERC 721 plasma, because as soon as you start dealing with non-fungible assets, things at least seemingly become a lot simpler. So I've been thinking a lot about that. One of the main simplicities is that you can no longer kind of create things out of thin air, because at least how I'm thinking about it is everything is created on Ethereum and then put into plasma. So if you have an invalid transaction, you basically can only exit what already exists. So that kind of limits the attack vectors there. So that's kind of something I'm also making a spec for, and I'd be able to share that too. The one downside to this right now is that I'm kind of thinking about how the fees would work, because you get a lot of benefits, at least so far, I think, from like being able to eliminate a priority queue and confirmations if you're just dealing with non-fungible assets. But to pay fees or to like exchange an asset for something, then it kind of looks like it might be more of an add-on to the UTXO Plasma MVP as opposed to a standalone. But yeah, for supply chain things, it might be good as a standalone.
Mm-hmm.
Yeah, I can share that too. It's still a work in progress, but
cool. Yeah, you've come up with like a lot of interesting and awesome spec designs, and like I think everyone is really building and on top of and appreciating a lot of them.
Yeah, and then kind of the last thing I've been thinking about is basically, so right now it's a lot simpler with accounts if both the kind of sending party and the receiving party sign and submit confirmations. And if you're just doing accounts, this is basically a huge pain. But as soon as you get into kind of a more trading exchange thing with atomic swaps, all of a sudden it makes a lot more sense, because the sender and receiver are also like basically fulfill both roles. So then having both parties do a confirmation of the end state is significantly less of a pain and seems more reasonable.
Oh, really? Oh, that's cool.
I think so. But yeah.
Okay. Yeah, that's cool.
Yeah.
Yeah, because that proof is sometimes kind of a big thing.
Yeah. And going forward, I'm really want to try to, right now I think the no confirmations may be overcomplicated, so I want to try to slim it down and see if I can do better.
Cool.
Yeah.
Awesome.
That's kind of where I'm at.
Awesome. That's a lot of awesome research. I think everyone will likely be building on top of the results of that. That's really cool. Thank you.
Awesome.
And then Cosmos team, what have you guys been getting up to speed on things?
So what we're working on is how to use Tenement Core as a client for the child chains. And so in the current design, so we're currently working on a spec for this, so that like that you have like separate the token movement from the staking. So like staking on Ethereum on a root chain contract informs the validator set of Tenement Core, which means that like validators can always withdraw and delegators can always unbond, even if the child chain starts screwing up. And then in order to allow the token movement, we're working on a peg zone so that we can have a secure two-way peg between the hub and Ethereum so that we can move tokens into Cosmos and then over IBC into the Plasma child chains.
Oh, cool.
So we have like the peg zone is like well on the way, and the staking spec, like for the staking part, we're working on the spec right now. That's much where we are.
Is that code open? I would love to.
Yes.
What you're, yeah?
Yeah, the peg zone code is open. It's like, we're just currently wrestling with Solidity a little bit, but.
Okay. I would love.
Biggest challenge, go ahead.
Oh, no.
The biggest challenge and probably valuable to get you guys just thinking about it is so you have the Ethereum chain, generating state updates, and now we're trying to get the state updates from the Ethereum chain to change the way intermittent consensus works. And so we're just trying to we've been sort of running through what the threat model is for that, and what the easiest way to do it is just have every Cosmos, every intermittent node sort of query an the Ethereum chain state at in between every round. And the biggest problem with that is that if they have different views of the Ethereum network, the chain will just stop until those views converge. But Tendermint is pretty resilient against that kind of situation in the sense that nodes won't crash or anything. They'll just wait until everybody's views converge and then start moving forward.
Yeah, and another thing is, I think this is not relevant for people that want to do Plasma contracts on Ethereum in particular, but for Tendermint native stuff and Cosmos native stuff, it could be relevant to design it where the token used for staking is inherent inside the chain itself rather than inside Ethereum.
That's what we call staking. That's what we know how to do, and what we're trying to figure out how to do is to have token staking on Ethereum. Yeah.
So I think for you guys, I guess if it works in the way that you normally expect, then build the other way later, I presume is a good strategy perhaps for you guys. But ideally, supports both. But yeah, I think we could definitely jam on possibilities along that context. Right now, I don't have easy answers beyond write Tendermint in Solidity, which I think nobody prefers to do. but that's anything that comes up for me.
Solidity, I think that's doable.
Yeah. So we will have the ability to detect fraud proofs in Solidity, so that way we can.
Cool.
So our biggest challenge there is our serialization format is extremely unfriendly in Solidity.
What do you guys do for serialization?
You don't want to know.
It could be worse. It could be proto buffs.
It's worse. Or it's better. It's different.
It's different. Yeah.
It's different. We're going to have to invent a little bit of a Solidity-friendly serialization format for the podcast.
Oh, okay. I mean, don't most people do the Ethereum binary serialization format, like this one they use for the PDP layer? I assume. Is that what most people do in Solidity contracts? I have no idea.
Fixed byte offsets.
Yeah.
Fixed offset data structure is the most Solidity friendly thing.
Okay. So everything hard coded in.
Do it right now our current serialization is reflection based.
Okay.
And base data types and stuff like that. We'll have to make something simpler.
Okay. Carl, you seem bemused.
Yeah, I mean, It's the Wild West. But I'm curious if you have like open or if you have written down kind of like the things that you're kind of working on slash like struggling with. I'm just curious because I want to like look at it and kind of understand the problems in more depth.
Yeah, so I mean, at the moment, you can probably follow. We on GitHub we have like github.com/cosmos/Peggy, which is sort of this like peg zone kind of thing. Which you know, that's the first part that we have to tackle, and once that peg zone works, then it's a matter of like converting that into this like plasma idea.
Yeah, and we also have github.com/cosmos/plasma. It's like preliminary ideas on. I'll send you the links after as well.
We'll post
Yeah.
in the chat as well.
And
Yeah,
post
yeah.
a blog post by next week.
I love blog posts.
Also, any links in the chat will go in the video description. So please post everything.
Cool.
Cool. Yeah. If it goes in the chat, much easier for us all. Okay. Cool. And then I guess we talked about what the Taiwan team is up to. Are there any other contexts from the other members, or possibly the consensus people? You guys are primarily observing right now and keeping up to speed, right? That's the current.
Yeah, it's keeping up to speed. So we'll be working on client implementation in due course, but our focus is currently elsewhere.
Okay, cool.
It's good to be part of this conversation. So thanks very much.
Yeah, absolutely. So I think as you guys, if you guys need to, in terms of spinning up an implementation, is the primary blocker around resources right now internally inside Consensus? I know you guys are all really busy working on stuff.
Yeah, so it's we're focused actually on building a client. So that's sucking up, hoovering up huge amounts of resource. So and on the other side, in R&D, we're working on sharding is our top priority at the moment. So that's kind of taking most of the bandwidth. But yeah, the plan is definitely to be working on Plasma or Plasma-like implementations. We're looking at, in particular, interest in privacy and enterprise blockchain. We can see some good synergy there.
Yeah. One thing that ended up happening well with the Lightning Network calls and the Lightning Network participants in the various implementations was that, everyone had their own, awesome specialty. They had different. So another version was doing a system that would be really good for embedded systems, and one that was like, oh, we're going to focus on like Node and like helping nodes operators make it as easy as possible when it comes to operating. And another was very like design and front end focus. And I think like a lot of the various implementations of Plasma can similarly have different focus. And I definitely could see the Consensus implementation having an enterprise orientation / a private chain orientation for sure. But yeah, there's a lot of awesome opportunities and different approaches to different problems that like everybody sort of has their own specialty. Was what ended up working out. I guess we could do like some quick Q&A as well. I don't know. What do you guys think?
Could I add something?
Yeah, for sure.
Cool. So I don't think I mentioned this on the last call, but basically, if just by being careful about how you Merkleize the transactions before you include them into the kind of fixed Merkle tree that is included in the root chain, you can basically just get basically performance gains. Just the easy example of this is for exiting. You need to know that a transaction was included, but you don't really need to know its inputs for Plasma MVP. So if you Merkleize that together, you're only dealing with like a 32 byte hash instead of like the positions and stuff. So yeah, that's just a cool, simple optimization.
Cool, thanks.
Cool. And there could be eventually future replacement for Merkle trees, which might be possible, but who knows?
Yeah.
Cool. Okay. I guess we could do quick Q&A. And if there's no questions, we can maybe end the call early and then have a much longer call in 2 weeks from now. Carl, did I say something bad?
No, you said something great. I mean,
Okay.
this is not a question, but I will advertise the fact that I'm going to be working on some presentations on both sharding and plasma. To kind of, I think that these design patterns and the way that we're talking is clearly something that is, if you know the design patterns, you have a lot of power and that you can build scalable blockchain applications. However, unfortunately, the number of people who are aware of the space, and it's not that complicated, it's very few. So we just need to like express ourselves better and get everyone working on these things. Everyone can do it.
Yeah, there's always like in this space, what I've noticed is there's a couple items in the toolbox, on a fundamental level. Okay, this is a bit of a side point because like I feel like there's not too many questions today, so I'm like I feel like if Carl gets to do this, I wanna do my commentary as well. Is that like I think like I totally agree about this toolbox thing, and this is sort of like maybe relevant for like I don't know. I think a lot of people are in this call because work on Plasma. A lot of people watching this call are interested in Plasma, but there's a lot of like this fundamentally is about like mechanism design and crypto economics. So it's sort of like what are those items that Carol is talking about? And I think it'd be fun to go over sort of like getting up to speed in the space. And my opinion is that everyone like is going like if you want to be doing mechanism design, it's totally backwards in terms of the advice that you're getting. Like people are like, oh, read current papers, and then you get so intimidated, and then you're just like, I don't get any of this crap. I don't know what is going on here.
100%.
And it's just like, oh, there's a sigma, there's an epsilon. Okay, I understand those symbols, but like I don't know what they mean, right? But honestly, like if you want to get up to speed on this space, like there's like a handful of tools that we use. There's probably like 15 tools that we use, like some that relate to time, some that relate to randomness, some that relate to like certain kinds of like data, like compression and like representation of state that you're committing to. So you like commit to something and then later on you can't back out of it, like basic things like that. Like I feel like enumeration of the toolbox will like help like the space grow really, really fast. My personal advice is that okay, I have a working theory that the fastest way to learn about the blockchain is to read and don't find the solution until you try to solve this problem for at least 4 to 5 hours. It's called it, and like it's not that unknown, but like I feel like if you haven't heard of it, I think a lot of people have heard of it. The blue eyes problem. If you understand the blue eyes problem, I feel like, and if you can solve it on your own, like that's even better. But honestly, spending a couple hours trying to solve it and then reading the answer will help you probably the most in getting up to speed with the blockchain.
Okay. Blue eyes?
Yeah, blue eyes problem.
Alrighty.
The reason for that is because you deal with issues of, that basically you face in the blockchain. There's time, there's ordering, there's like basis of like group coordination. Oftentimes the problem doesn't specify that. When you read the problem, the main thing you have to understand is that that everybody on the island is a perfect logician, and they know everybody else on the island is a perfect logician and will act in a perfect logician way, and everybody else has knowledge of that. All the instruction and explanations don't specify that, but if that's specified, that's like an important point.
Yeah.
Do you know what I mean? Like those of you that like have heard of this problem, like it's basically blockchain, right? Like it's basically blockchain problems.
Basically.
Yeah. I have a working theory that like, it's like the two things that like probably predates the blockchain in terms of influence is Git and the blue eyes problem. That's my working.
Yeah. Yes, sir.
Anyway, sorry, that was a long rant. Okay, for real. Okay, okay. Questions about plasma and stuff like that. No, there's no such thing as silly questions. Problems we're working through. Problems where you're like, I don't know how this should work, and stuff like that. Right now, sort of a weird week because it seems like everybody is in flow and developing things. So it's like probably less questions would be my guess this week. But I could be wrong.
David, could you talk a little bit about how you're working? How you're start thinking about mapping each balance to an account, or how you're merging this UTXO concept into your VM.
Yeah.
Yeah, this is David. Yeah.
Yeah. So with merging UTXOs to simulate accounts is one thing, and I can explain that. Or is that what you're asking about?
Kind of, yeah. Well, basically, have every account should have a way to know where to exit to,
Mm-hmm.
right? And so, it's kind of basically, yeah. That's my question.
So yeah, the simplest way is kind of just building accounts on top of Plasma MVP using account simulation, and so that's basically just having someone hold all their balance in one UTXO, and then when they spend it, they give themselves change, and then when they receive a UTXO, they just feed it back into themselves. Mm-hmm. So that's the simple way to do it. I'm really interested in kind of a pure account-based way, and the way, at least to me, that's looking right now is basically where everyone has everyone has different accounts for different currencies. All right, so different balances for different tokens. And then when someone wants to trade X token for Y token with someone, they basically, 4 accounts are referenced in the transaction. And without kind of the shortcut of Merkle hashing everything down before submitting it to the root chain, that would kind of not be viable. But I think it is with hashing everything down before it's included. And so you basically get all the 4 balances are basically 2 for each party, and you basically get the 2 tokens. You get X balances for both parties and Y balances for both parties, and then both parties sign off on the new balances, and then once the block is submitted, submit confirmations that the balance is valid. And that's kind of the gist of it. There are some downsides in that right now it's super single threaded in that you have to wait for the way it's set up, you have to wait for a confirmation before you can basically use that account again. So I'd say that's the main weakness, and I'm sure, yeah, so it's a work in progress, but that's the gist.
Cool.
Does that kind of answer?
Yeah, I think so.
Okay.
And it's enumerated in the spec in some ways.
Yeah, I haven't shared that. I will.
Okay, that one too.
I have a question for you, Joseph. In terms of getting rid of Merkles, do you see accumulators as being the most likely potential solution for that?
That's a possible way to go about it, but as trade-offs, I don't expect us to be doing anything of that nature anytime soon.
Okay. What other things do you see as kind of being on the horizon?
Oh, that's what I presume could happen as a drop-in replacement.
Okay.
There's some research going on at Stanford.
Mm-hmm. Okay.
Yeah, right now I don't expect that anything like that to happen. But I was just sort of saying oh yeah, there could be more optimizations type of stuff, but I don't see them, and I think the optimizations that you're talking about is probably the most viable thing right now. And I think a lot of the how do I put it? The math isn't double checked on other methods. Yeah. Other questions?
David, accumulators are really good for very compact proofs of non-membership.
Yeah.
You know, like,
And membership.
and membership, but especially non-membership.
Yeah.
Because you don't need to make assumptions about Merkle trees that you typically need to make for non-membership proofs with non-membership proofs, because you don't need to assume that they're sorted.
Yeah, yeah, yeah. And this isn't, you know, the problem set I was talking about with David was not, you know, a more complete problem set that me and Zaki have been discussing for several months. It's a more constrained, specifically in the context of Merkle trees, and only set inclusion, not exclusion, and it's only for, it's not for, you know, UTXO contexts, but it's specifically for generalized Merkle tree contexts. Yeah. So ideally, there's like a better solution. And I think, you know, me and Zaki have been, you know, talking about this. Zaki is like really, really, really smart with it when it comes to these types of things. And can probably elucidate far better than I can.
Yeah, and probably talk to Dan Benet a bunch more about this stuff when I get
Yeah, yeah, yeah. It'd be really cool to like maybe like co-author a paper or something about that.
Yeah.
I've mentioned that to him as well, and like he's like, yeah, that's good. And when are you next in the Bay Area, Zaki? By the way,
March 3rd.
Okay, we should all meet up at in Palo Alto. In
Yeah.
that context, yeah, that'd be a lot of fun. Cool.
Yeah, we'll put a meeting together. I think that's a good idea.
Yeah, that could be a lot of fun for everybody.
We could do one of the lunches. We could do an open problems and blockchain scalabilities.
Yeah, yeah, yeah. That'd be good. There's a lot of open problems. They all tie together with each other.
Yeah.
Oh, so Carl, I think like for the thing that you were talking about, like creating these like doc materials and stuff, right? Learning materials. I think one very interesting thing to do would be like kind of really enumerating the differences between a lot of these methods that, like, you know, to someone who maybe isn't as accustomed, like experience with them, seem very similar. Like the ideas of like Cosmos IBC versus Plasma versus Polkadot versus Ethereum sharding, like explaining what the differences are between these, what are the trade-offs that are being made. I think that would be like, I haven't seen like a really good, like comprehensive resource comparing all of these yet.
Yeah, yeah, absolutely. And also, I doubt people even know what they are in the first place in a concise way, right? So we need to. I'm currently working on the, you know, the Ethereum or the sharding, Plasma, Casper kind of, you know, what those things are. But let's talk later, Sunny, and let's get the Cosmos, you know, IBC and whatnot also enumerated, because that absolutely 100% needs to be part of this kind of you know, knowledge base of real blockchains.
Yeah, and Polkadot. We shouldn't forget that.
Oh, and Polkadot, of course.
Yeah. And then are there other contexts? Obviously, we don't want to include stuff that doesn't work, like IOTA, but
yes.
Exactly. Why are you guys laughing? That's not a joke.
Vlad has been working on his like whole sharding thing and like Nate
right.
Implementation already, which is like super cool.
Cool. All right, yeah, that could be pretty interesting. Okay. And then what else? I don't know. There's like other cool stuff. Like, okay, there's DAGs that don't work, but there's DAGs that are fairly interesting. Like, have you seen the Spectre paper? I thought that was pretty interesting. Yeah. And what is it? They have some other name, Phantom. I forget what it was called. As well. They're all scary names. But yeah, there's a lot of cool emerging research when it comes to this, and definitely comparative analysis. What's interesting is a lot of the emerging projects that do these types of things when it comes to these types of scalability have similar solutions when it comes to solving the problems in specificity, right? You know, like things like, you know, prepare commit type dynamics, how you deal with time. Like it's pretty interesting how like eventually you run into the same problems, and it'd be interesting for these various projects to start looking at each other because, you know, there's basically the same. They're all processing things. But yeah, I think that would be pretty helpful. And I think like basically, I think Carl and the Cosmos team get greater visibility into this as like you have visibility into different contexts, and I think it should be pretty helpful with both Plasma and the respective projects. Thank you.
Cool.
Cool. I guess this is a low Q call in terms of questions. Are there other topics to do before we conclude? Carl, do you as a co-host, do you?
I sign off. I think this was lovely and quite successful.
Yeah. This has been a blast.
Yeah. And I guess we're gonna have our call 3 hours earlier, 2 weeks from now.
Yes.
Okay. And did the video for the previous call get posted as well? Oh, it will do. Okay.
Yep.
Cool.
And this will be posted. So I'm gonna post this on, I think, Monday on the, next week or Tuesday.
Perfect. Yeah, whatever. Okay, cool. That sounds great. It's wonderful meeting you all in terms of the new people in this call. Definitely, first call as you get to know everybody. But, the format of this call is, definitely speak up. There are no embarrassing questions. There are no embarrassing dynamics. You can be straight up grilling us with like what you presume are basic questions or not, or very complex questions. But the key is, maybe before the call, maybe think of stuff you want to ask. If there's any like issues that's, maybe can save you 10 hours of time, even just like asking people that have been thinking about this topic. But also, just context around that. Just don't any apprehension around speaking up. We're very, very, very eager to have that as well. And then I think maybe more focus on, I think next week we can be focusing on some nitty-gritty information.
Could you repeat the last part?
Oh, I said next week, not next week, 2 weeks from now we can focus on like nitty-gritty implementation details.
Cool.
Things of that nature. I think David has some stuff written up. I will review it and get back to him, but also, we can maybe talk about that in greater detail as well.
Cool.
That could be really fun, going over that together. So it's really good. And see you all in 2 weeks, bright and early for it.
All right, thank you. See you. Happy birthday, everyone. It's everyone's birthday today.
Whose birthday?
It's everyone's birthday.
Oh, it's like it's unbirthday, right?
I mean,
everyone's unbirthday.
I'm redefining day to be 365 days.
Oh, okay, that works. Sorry, I didn't get the context.
Very bad. All right.
Oh, we should all have worn party hats. That would have been fun.
Next time.
Okay.
Wait, can next plasma meeting be silly hat meeting?
Oh my God, we need a theme.
100% yes.
As long as we don't do any technical discussion.
Who would want to listen to that in their recording?
Yeah, exactly.
Everyone.
Okay. Oh, we could also prank people because some people are probably listening in their car, like podcast style.
Hey, we love you, audience. We love.
Okay. See you.
Bye, guys.
Bye-bye.